What's up, 8th grade? Today I'm going to guide you through lesson 2.1, how body structures affect evolution. So let's start with the warm-up. Okay. We're comparing the front limbs of a human and a cat. Both have the same bones, but these bones look very different in the human and the cat. So using careful observation, describe at least two differences between these two limbs. Start with the hand bones. So one important concept in biology is that the structures of organisms depend on their functions. So what's the function of a human hand? Humans are very unique because their hands are really good at using tools. So primates and apes used to walk with their hands, but we don't really find that useful. It's much more useful that we can use our hands for tools. So they're very flexible and versatile. Whereas a cat's paw is primarily used for what? That's right, walking, stalking, pouncing, clawing. So you'll see that the humerus bone, the funny bone, is pretty similar. I mean, it's a little different between the human and the cat. The radius and the ulna, both of them have them. They're pretty similar, except for the cat's ulna is pretty long. The distal bones are the big difference. So humans have 5 fingers. Cats don't have 5 fingers. Well, let's see Taz's paws here. He got 4. Oh, he's mad. He's got 4 main paws, and then he has kind of a thumb too. So it's not that different, but and some cats actually have an extra one. They have 6 fingers instead of 5. But you'll see the distal bones are shaped differently. So just note those differences, and that is important. Let's move on to part 2. So now we're going to compare more front limbs between the wolf, the direwolf, the fruit bat, and Titanotilopus. Okay, so first we have the front limb of the wolf. Same thing, so humerus, radius, ulna, distal bones. So just record your observations about the direwolf front limb. Bat front limb is interesting. So we have that same one bone, which is the humerus in us humans. Radius, ulna, very small ulna here. And you'll see that the distal bones, or the finger bones in bats, are extremely long. And what do you think they're used for? And this is I believe it's a Titanotilopus. This is the giant, or the ancient camel, basically. So not much ulna there. The distal bones are just kind of long and not really separated, except for maybe the bottom. So just record your observations about each, the unique parts of each. Now we can quickly consider information about how they use these front limbs. So let's take a look. So the direwolf, it's a wolf. You know what a wolf is. So it's a predator that needs to run and attack large organisms for food. So not too different from the modern gray wolf. It's what you would expect, basically, except bigger. Fruit bat. So they use these distal finger bones to fly. That's an important way that's kind of like their job in their environment, or their niche in their environment. You can see the structures here too. And the giant camel, let's see, it walked on its 4 legs on land, stores fat, walks long distances, much like the modern camel. So its feet have to be really sturdy to walk that far, to walk long distances. It's not like a cat that has to jump, or a wolf that has to stalk and pounce and all that. So in this part, please consider how their environment affects the structures of their front limbs. So what might explain the differences in shape for the bones of the front limbs in these 3 animals? Well, they all have to use their front limbs to survive, and to survive in their environment, which will help them reproduce if they do survive, which is natural selection. So there's a big connection between natural selection and evolution. You guys can skip the homework because I don't want to give you guys too much. They're just asking you to basically find shared structures in the evolutionary tree, but that's okay. I want you to think about wolves, bats, cats, and giant camels today. That's all. See you later.